in this section, we're going to talk about a brand new field called encrypted deep learning. And this takes the same core technology that we were talking about in the last segment on encrypted federated averaging, and applies it to the actual prediction of a deep learning model, meaning that when we complete these series of lessons, we're going to be able to learn how to predict on encrypted data while the model that you're using for prediction is also encrypted, right? So we're going to be able to take all the parameters in our model and all the parameters that are in our data set, encrypt them, and be able to run predictions while it's in an encrypted state. And in order to do this, the first thing we're going to do is review our additive secret sharing technology that we learned about in the last series. And then we're going to sort of build upon that, adding sort of more operations than just addition. So first we're going to talk about subtraction and public scalar multiplication. Then we're going to talk about how to multiply two encrypted numbers by each other. This actually turns out to be quite challenging. And then we're going to jump into how libraries can enable us to do this with a bit more ease without necessarily having to roll our own cryptography ourselves. But of course, the first lessons are just to give us an intuitive sense of what is actually happening under the hood in these frameworks. Then we're going to tackle a few different projects. First, we're going to build an encrypted database using this technology. So we're going to look at encrypted computation in general, and then we're going to apply encrypted computation to actually do encrypted deep learning in PyTorch and Keras. So without further ado, let's jump in. So in this first lesson, we want to review additive secret sharing. In particular, we're going to use a slightly different code example here, and this is pulled with permission from Morten Dahl's excellent series on secure MPC. Highly recommend checking out this series if you're looking for sort of the next level of detail around how these crypto protocols work. And this should look incredibly familiar to the last lesson. So we have encode and decode. So this takes our decimal numbers and encodes them using fixed precision, right? And so we've the only change that you would see from the previous is that now we have a precision integral and a precision fractional. And then we have our same kind of encrypt and decrypt functions. So this takes our sort of encrypt takes a decrypted number and converts it into 3 shares specifically, and decrypt does the opposite, right? So in the previous segment, we were looking at sort of arbitrarily large numbers of parties to work with, but in this particular case, we're going to focus specifically on 3-party MPC. And then, of course, this is the addition logic that we saw before. And so now, if you remember from before, we can actually kind of do this all together. So I guess I should break this apart so you can see. So we have X, which is 3 sort of super large shares. We have Y, which looks quite similar. And if we add them together, we get several large shares. And again, this is addition modulus a large prime. And then we can decrypt Z. But this is still sort of, you see how it's a large integer because we've encoded it with fixed precision. So this is why we decode the decrypted number Z, and it actually gives us 7.79. So, which is very close. We have a slight rounding error, which is just something you have to be okay with when using fixed precision. And so here we are. This is exactly what we were working for in the last time. So this should still feel incredibly intuitive. And then what we're basically going to do in the next section is build a few more of these functions, right? These things that operate on top of these sort of tuples, right? So the important thing to walk away from here is that we're encoding each number as a tuple of length 3, right, of these large integers. And then in the next segments, we're going to work on how we can do other operations that combine these tuples, or that perform functions over these tuples to do things like subtraction, scalar multiplication, or encrypted multiplication. See you in the next section.